So the last thing we discussed in the last chapter was about an AC generator. How does an AC generator work, or what does it consist, and how does it generate that alternating EMF?
So it changes the energy from chemical, then to heat, and then mechanical, to then electrical.
You are talking about the usual generator that we find in apartment buildings and all. Okay. But how is that mechanical to electrical conversion done?
So it changes at a constant rate of omega. Is that right? Like
It
it
not
keeps.
it changes. Yeah. So tell me, what are the parts of an AC generator?
Sure, I forgot.
Okay, just a moment. It works on uh, Faraday's law. The principle is Faraday's law actually. So there are permanent magnets, and the permanent magnets are used to produce a magnetic field, of course. Okay, and in that magnetic field, a coil is made to rotate. In an ideal case, we assume it rotates with a constant angular velocity omega. A coil rotates in a magnetic field, then the flux through the coil will keep changing, and that is how the EMF gets generated. So this is the basic idea behind the working of an AC generator. In the rotation of that coil, mechanical energy gets used up, and due to that rotation, electrical energy gets produced. So mechanical to electrical energy conversion takes place. Fine. And the EMF that you get, if the loop is, or if the coil is rotated with a constant angular velocity, is of this form: E naught sine omega t plus some constant, where that constant is the initial angle between the area vector and the magnetic field. And the peak EMF E naught that you can get from an AC generator is B, the magnetic field that is there inside it. We assume it is uniform. A, area of the coil. Omega, the angular velocity with which it is rotated. So faster the rotation means greater the angular velocity of rotation, greater the peak EMF that you can get. Okay. Let us understand this equation first. Alternating EMF. E is equal to E naught sine omega t. Let's ignore that constant for now. Okay. As time passes, this bracket keeps changing. The value inside this bracket keeps changing, and sign of that also will keep changing. So basically, this is a variable EMF. Okay. So first thing we can tell for sure is that this is variable. Okay. Rishi, tell me, when t is 0, how much is the EMF?
Sir, B BA omega.
I'm asking you to substitute time as 0. How much is sine 0?
Sine 0 is 0.
0. So what does the total EMF become?
Uh,
No, t is 0 here, and you know sine 0 is 0.
oh, E naught only.
Yeah, it's E naught multiplied with 0, no?
Oh, that, yeah, sir, yeah.
Then the whole thing becomes 0, right? And when time becomes non-zero, it's possible that the sine function gives a non-zero value. Then the EMF also becomes non-zero, so it keeps varying. Uh, Generally, from mathematics, you tell me, when does a sine function start repeating? Like after what interval does the sine function start repeating?
So 2 pi, right?
2 pi, correct. That is the period of repetition of the sine function. Fine. So if you have something like, let's say y is equal to sine x, fine. Whatever happens between x is equal to 0 and x is equal to 2 pi repeats after 2 pi. Fine. Now here the function we have is E is equal to E naught sine omega t. In place of x, we have omega t. Now when x changes by 2 pi, the sine function repeats itself. That means in place of x, we have omega t this time. When omega t changes by 2 pi, okay, as time goes on increasing, omega t value will keep changing. So whenever omega t changes by 2 pi, the EMF function repeats itself. Is this step clear?
Yes, sir.
Right. So basically, this EMF that you have here, the alternating EMF, is this function is a periodic function. Okay. The function repeats, means the values of EMF will repeat after every interval of 2 pi. Or whatever pattern the EMF was following, that pattern repeats after every interval of, no, I should not say interval actually. No. Whenever omega t changes by 2 pi, the pattern repeats itself. Okay. Now if omega t changes by 2 pi, it means t changes by 2 pi by omega. So whenever time changes by 2 pi by omega, the EMF function will repeat itself. Is this clear?
Yes, sir.
So this 2 pi by omega is called the period of this function, time period of this function, or equation you can say. Okay. And if 2 pi by omega is the time period, you can write T naught is equal to 2 pi by omega. By definition, the frequency, see what is time period? Time period is the time taken to complete one cycle and repeat the cycle. That is time period. The inverse of time period is what we call frequency. Basically, frequency is number of cycles per second. Okay. Time period is number of seconds per cycle. Inverse of it, number of cycles per second, is what we call frequency. So you can say frequency of this function is 1 by T naught, that is omega divided by 2 pi. Okay. And when we write a sine function like this with omega as the coefficient of the variable is time. Omega is the constant angular velocity with which we rotate the coil. Omega here is called angular frequency of this function. Are the terms clear? Omega is angular frequency. 2 pi by omega is the time period. Omega by 2 pi is the normal frequency.
Yes, sir.
Right. So tell me, what do we mean by time period?
So like how
Hmm.
much time it like changes per second?
No, you are telling the definition of frequency.
Oh, then it's the opposite. So it's like how much time it takes to do one.
How much time it takes to complete one cycle. Okay, that is what we call as time period. Fine. So if you look at the function of, sorry, not function, the graph of y is equal to sine x. This is how it looks. You must be aware of this graph. When x is 0, the sine function is 0. When x becomes 90 degrees, that is pi by 2 in radians, the sine function assumes its maximum value of plus 1. Right? So this is the graph of the equation y is equal to sine x. It keeps varying between a maximum of plus 1 and what is the minimum value of y is equal to sine x?
0.
Well, you look at the graph and tell, don't you think sine can ever be negative?
Minus 2 pi.
2 pi is those are all angles.
Oh, minus 1. Yeah. Yes.
Yeah, okay. The minimum value of the sine function for any angle. Oh no. And you can observe the period of the function also. whatever happens to the graph in the interval 0 to 2 pi, that is this interval, it just repeats after every interval of 2 pi. Okay, that's why we say the period of the sine function is 2 pi. That's fine. So y is equal to sine x has a maximum of +1 and a minimum of -1. So Rishi, you tell me, if the function was, let's say y is equal to 2 sine x, what would its maximum value be?
Oh, sir.
+2. Minimum value?
-2.
-2. Right, right. And so on. So if you generally have y is equal to a sine x, okay, the coefficient of the sine function is a, that function would vary between -a and +a, right? Now the EMF equation we got here, alternating EMF equation, is E is equal to E naught sine omega t. Okay, now as time varies, omega t will keep varying, the sine function will keep varying. The sine function ranges from -1 to +1 as time changes. But the function is multiplied with E naught. That means the EMF varies from minus E naught to plus E naught. So plus E naught basically is the peak EMF. Is this clear?
Yes, sir.
Okay, fine. So tell me the formula for frequency of this function.
The frequency is omega by 2 pi. So, which is
Correct. That is what I asked. Formula for frequency of the function omega by 2 pi. Fine. So try to answer this question. Write the equation of alternating EMF whose peak value is, let's say, 200 volts and frequency is 50 hertz. Right? Any answer?
2 minutes, sir.
Okay.
Sir, I might be wrong, but it's 200 into
Continue.
sine 100 pi into t.
Okay, you're saying 200 sine 100 pi into t. Okay, let's see. Now peak value is 200, so you got the 200 part correct. And frequency is 50 hertz. You know frequency is omega by 2 pi, so you send the 2 pi this side. Your answer is correct. Okay.
Oh,
So this equation has a peak value of 200 and its frequency is 50 hertz. That's fine. But there are other possibilities as well. See, not only the sine function, you can write it in terms of a cos function as well. This is also correct. You can even add a constant inside that function. Plus, say pi by 2 or pi by 3, it's your choice. You can add anything. Okay. The coefficient of time is what determines the time period or the frequency. These constants don't matter. Okay. And the coefficient of the sine function determines the peak value. This is always E naught. This is always omega, irrespective of what constants you write. Is it clear?
Yes, sir.
In fact, you can consider this function. When you add a constant inside the function, okay, like see here we have the graph for y is equal to sine x. When x is 0, the function, the y value is 0. Okay, let me copy this just a moment. Right. Now, suppose you add something to x, only to x. You're not adding something to the function. You're adding something to x. Then you will, let's say you add 1. You get the graph like this. So this is the graph for y is equal to sine of x plus 1. Observe the difference between the upper graph and this one. The upper graph passed through the origin. Y is equal to sine x passes through the origin. Okay, this point is what I'm talking about. When you add something to x, when you add a constant to x, and when you add a positive constant, the graph simply shifts to the left. That's all. And you can see you added a constant of 1. Then the graph shifted to the left by 1 unit. That's why it's now passing through -1. Okay, suppose you add 2. Let me show you that graph also. You add a constant 2 inside, then the graph will shift by 2 units to the left. The time period will not change. The peak value will not change. Only the initial value will change. Yeah, this is the graph for y is equal to sine of x plus 2. You can see it's not passing through the origin. It is passing through x is equal to -2. You added 2 to x. So the graph shifted to the left by 2 units. It is now passing through -2. So did you understand that the constant inside the sine bracket does not affect the period or the peak value? Is it clear?
Yes, sir.
The peak value here is still +1. Negative peak is -1. Positive peak +1. Negative peak -1. Fine. It only adjusts the position of the graph along the x-axis. That's all. So you can say that the general equation for alternating EMF is E naught sine omega t plus phi, or phi naught, you can call it whatever you want. But irrespective of that constant, frequency and time period always depend on this omega. Peak value always depends on this E naught. Okay. Now, when you connect this kind of EMF, see in a generator, this is the kind of EMF that we get. Even in hydroelectric power plants or thermal power plants, this is the kind of EMF that is given as the output. Do you know how a hydroelectric power plant works? The basic mechanism, turbines and all.
I'm not really sure, sir.
Okay, so water in a dam, when it flows down with a high speed. Now that water flowing at high speed is made to pass through a turbine. Turbine you can assume is like a fan only. Okay, when water passes through it, it rotates the blades of the turbine. And those blades of the turbine, they are connected to a shaft, which is in turn connected to a coil placed between very strong magnets. So when water passes through the blades of the turbine, it rotates them. That rotation rotates the coil, and that produces the EMF. Okay, so basically there we use the potential energy of water stored in a dam to drive the turbine, to rotate the coil inside the magnetic field. And it generates an EMF like this. So usually the voltage that we get in a household power socket is alternating voltage only. You don't get a DC voltage. Is this clear?
Yes, sir.
Huh. Now, when this kind of voltage is connected to an appliance, how much power it dissipates, how much current passes through it, those are the calculations that we basically do in this chapter. And when we say appliance, we mean resistances. Okay. Or you can connect to resistance, capacitor, inductor, series circuits also, combinations of them also. Now, in all those calculations, we'll be interested mostly in the average current that passes. See, this is an alternating EMF. This is a variable EMF, right? When you make a variable EMF, when you apply a variable EMF across a resistor or an inductor, whatever, you will get a variable current. And if current is variable, the power consumed or power dissipated is most likely to be variable only. But usually that is not what we are interested in. Have you ever read the specifications of any electrical or electronic device?
Yes, it is like safety rating or something like that.
Safety ratings will be there, and power consumption ratings will be there. Suppose you purchase a bulb, okay? On a bulb, a wattage will be written. Like let's say, like the CFL bulbs and all. Let's say you have a 12-watt bulb. That means it consumes 12 joules of electrical energy per second. But see, you connect the CFL bulb or normal household bulbs. Where do you connect? You connect to the power socket only, and they are supplied an alternating voltage, not a direct voltage. If you are connecting them to an alternating EMF, the current passing will be variable, the power dissipated also will be variable. But how are they giving you a constant power rating? How are they saying the bulb dissipates only this much constant power? Basically, this is some kind of an average. It's called the RMS value, root mean square value. The actual power consumed by the device keeps varying depending on the EMF that you supply. And the EMF you are giving is variable, so the power consumed by the device will also be variable only. But you should learn how to tell the RMS value or the average value of the power consumed, average value of EMF provided, average value of current flowing, all those things. So this is a little bit, I mean, this is slightly mathematical, not slightly, this is totally mathematical, but we will have to go through that once. So consider this function itself, E is equal to E naught sine omega t. Rishi, tell me, what is the peak value of this function? What is the maximum value of this function?
E naught, sir.
Plus E naught. Minimum value?
Minus E naught.
Minus E naught. Okay. And if you plot its graph, it looks somewhat like this. So this is the graph of y is equal to sine x. But if you change it to, on the y-axis you take EMF, on the x-axis you take time. You change the graph to E is equal to E naught sine of omega t. Then what you will see is that the peak value will be E naught. Instead of plus 1, you will get E naught. And the negative peak will be minus E naught. And the period of repetition will be 2 pi by omega, not just 2 pi. It will repeat after every interval of 2 pi by omega. Okay, that we have already discussed. Okay. Now tell me, in one complete time period, okay, let me mark one complete time period here, say this interval. From here to here. Just by looking at the graph and your own ideas, you tell me, you can see that the EMF is increasing from 0 to plus 1. Again, it is going down to 0, then going down to minus 1 and going back to 0. So there are some positive values and there are some negative values. So from your, I mean, based on your own logic, Rishi, tell me, what do you think is the average value of EMF during this duration, during this interval?
0, sir.
0. How do you justify that it will be 0?
Because it's this peak is the same and the negative like minimum is also the same, and both of them cancel out.
Okay, okay. See, not just by looking at the maximum and minimum, whatever positive values the EMF takes, it will take the same negative values for the same amount of time. So the average over this interval is going to be 0. Okay. Generally also for a sine function, average value over one complete interval will be 0, because in one complete interval, whatever positive values the sine function assumes, it will also assume the same negative values. Okay. So the average in one complete time period is going to be 0. Correct. So average EMF in one time period is definitely 0. Okay. Now consider a half time period interval. Let's take the positive half cycle. See, this is an alternating EMF. The part of the graph where the EMFs are positive, this part is called the positive half cycle. And the part where the EMFs are negative, this part is called obviously the negative half cycle. Okay, these are technical terms that you need to remember. Now you tell me the average value of EMF only during the positive half cycle, will it be 0?
No, sir.
Will it be negative or positive?
Positive.
Obviously it will be positive, because all values of EMF in that in that interval are positive, so the average will also be positive. Okay. What about the average value of EMF during the negative half cycle?
Will be negative, sir.
All values are negative, so the average value will also be negative. Can you guess how much that is?
Minus 0.5.
Minus 0.5. Okay, minus half you are saying. Okay, for the general sine function, the peak value is +1, lower peak is -1. So you are saying average of the negative half is negative half cycle is minus 0.5. That is not correct, because like how did you arrive at minus 0.5?
As the minimum value is -1, so
Okay, so you took the number between 0 and -1.
yeah, something.
Rishi, you consider a situation like this. Suppose there is a class of students. Okay, Isha, you also take this question. Suppose there is a class of students, and let's say the minimum score in that class is 20 marks, and maximum score in that class is 80 marks. If I ask you what is the average score of the class, how much will it be?
$50.
So you averaged 20 and 80. You took the average of the minimum score and the maximum score, and you are saying average score of the class is 50. Rishi, do you agree with this?
Yes, sir.
But no, that is not correct.
Sir, isn't it supposed to be like total marks by the number of students?
Total marks of all the students added divided by the number of students. So can you just tell the average value by looking at the minimum and maximum?
No.
You cannot. Okay. Isha, let me give you an example. Suppose there are 3 students who scored 20, or let's say 4 students who scored 20, and only 1 student who scored 80. Then 20 has more weightage, no? Average won't be 50. Okay. How much will the average now be? Add all these. 4 20s is 80, 80, 80 is 160. Divided by how many students are there? 5 students are there. So the average becomes 32 marks. Okay. So just by looking at minimum and maximum, you cannot tell the average. One case in which you can tell the average just by looking at initial and final values is when the graph is linear. If you know that the graph is a straight line, if you know that the distribution is a linear distribution, then the average value will be the middle value of the extremes. But in other cases, we cannot say. It may be the midpoint value, it may be some other value also. Isha, is this clear? Rishi, is this clear?
Yes, sir.
Right. So now The EMF graph, as you can see, it's a sine function, sinusoidal graph. Let me copy this graph. Okay. So see, this is the graph of y is equal to sine x, but we are discussing E is equal to E naught sine omega t. That thing you need to keep in mind. So the peak value will be E naught. Negative peak is minus E naught. And the period of repetition is 2 pi by omega. Okay, that you need to keep in mind. Okay. Now what we want is the average of the positive half cycle or average of only the negative half cycle. Let's consider only the positive half cycle for now. Now, the graph clearly is not linear, as you can see. It's a sinusoidal function, it's a wave shaped function. And we want the average of all these values. I think we had discussed recently in integration also, you must have learned how do you calculate the average value of a function, say y is equal to f of x in a certain interval. Any idea how to calculate average of any function in any interval? I'm sure we discussed this. We talked about average velocity, average acceleration. Then I think we applied that to average current or something. Okay. You all go through that. I'll just tell you the idea now directly. If you want the average value of a function y is equal to f of x, it can be calculated as integral y dx divided by integral dx. Okay, so basically you have to integrate the function with limits as the interval in which you want the average and divide that by the interval itself. Okay. So we are going to use this to find out the average of the EMF function in only the positive half cycle or only the negative half cycle or in whichever interval you want, you can find out now. All you need to know is integration. If you can do that, you can tell the average of any function. Okay, let us try this. Not directly with the EMF function. Let's take a simpler function now. Suppose y is equal to 5x. Okay, I want you all to calculate average value of y between x is equal to 2 and x is equal to 10. Do this, all of you. Use the integration formula that we have written above. Average value of y between x is equal to 2 and x is equal to 10. I'll just write it neatly. Any answer? Okay. Rishi, how are you trying to solve this?
Sir, 2 minutes, I'm almost done.
Okay.
Sir, is the answer 48?
We'll see. 48. Isha, what is your answer? Okay. Rishi, how did you calculate?
Sir, first
Did you
so the
use this
formula
integral
is,
formula or not?
yes, sir, that only.
Okay. You have to integrate y dx and divide that by integral dx. What do you have in place of y here?
5x, sir.
5x. So you will need to integrate 5x dx from 2 to 10 and divide that by the integral of dx, that also from 2 to 10. Okay, what is integral 5x dx?
5x square by 2.
5 times x square by 2, and you need to substitute limits in that 2 to 10
Sir,
divided
my
by.
answer might be wrong. My
Okay,
answer
we'll see.
might be
We'll
wrong.
see. What is integral dx?
5, sir.
Integral dx. Integral dx is only x. Okay. So if you substitute limits, this by 2 can be taken out. So the numerator will be 5 by 2 multiplied with 10 square minus 2 square. 10 square is 100, 2 square is 4. 10 square minus 2 square will be 96. Divided by, in place of x you put 10 and in place of x you put 2. 10 minus 2 is 8. 8 and 96 is 12 times. 2 and 12 is 6 times. 5 sixes, the answer is 30. Okay. The average value of y is equal to 5x between x is equal to 2 and x is equal to 10 is 30. Let's see if this is correct or not. There's a way to check also, because this is a simple function. Y is equal to 5x. It's like y is equal to mx. The graph is a straight line. This I got from Google. This is the graph actually for y is equal to 5x. Okay. It's a straight line. And we want the average value between x is equal to 2 and x is equal to 10. When x is equal to 2, y is equal to 5x. Y is 10 units. And when x is equal to 10, y is 5 into 10, 50 units. And this is a straight line. I told you, for a straight line, or when the variation is linear, the average value is always the mid value of the extremes. The extremes are 10 and 50 here. The average of 10 and 50 is 30. And that's the answer we got. Okay. So for linear functions, it's easy. Just take initial final value, divide by 2. You'll get the average value. So is the idea clear how to find out average of a function?
Yes, sir.
Okay. Just integrate the function in whichever interval you want the average and divide it by that interval itself. Isha, is this clear?
Yes, sir.
Okay. Now let us take a slightly complicated function. Suppose y is equal to sine x. You all know how y equal to sine x varies. Let me once again show you the graph. It's definitely nonlinear. And the problem now is to find out its average value in the interval 0 to pi. Means during this positive half cycle, we want to find out, or we have to find out, what is the average of the sine function. You both guessed it is 1 by 2. And I told you it need not be 1 by 2 because the variation is not linear. Okay. We have a mathematical method now. We are going to use that. So we want average value of y from, these are the limits, x is equal to 0 to the upper limit is x is equal to pi by 2. And how are you going to do it? Y average is equal to integral y dx, that is sin x dx, limit 0 to pi by 2, divided by the interval itself, or integral dx. There also the limits will be from 0 to pi by 2. Do this both of you. I'll give you 2 minutes. Generally, what is integral sin x dx?
Cos x.
Minus cos x. Okay.
Yes,
Okay.
sir, minus cos.
Yeah, it is minus cos x. Do it quickly, both of you. Any answer?
Sir, it's minus 1 by something.
What something? See, you can't give answers like that at this level.
I'm solving, sir, once.
And it cannot be negative. See, all values of the sine function are positive in that interval, then the answer has to be positive. Isha, any answer?
Sir, 2 by pi.
2 by pi. Okay, that will be correct. Okay. Integral sin x is minus cos x. So I'll write it here. Minus you can put outside cos x. And we still have to substitute the limit 0 and pi by 2. Denominator integral dx is just x. And that also from 0 to pi by 2. Okay, keep the minus as it is. Substitute upper limit cos pi by 2. Cos 90 degrees is 0. Minus substitute the lower limit cos 0 is 1. Divided by pi by 2 minus 0. So numerator minus of minus 1 becomes 1. Denominator is pi by 2. The average value is 2 by pi, which is not 1 by 2. Okay. So remember, what function have we taken here? Y is equal to sin x. For the function y is equal to sin x, the average value of the positive half cycle is 2 by pi. Rishi, is this clear?
Yes, sir.
Practice these once. Okay, not once, twice or thrice you practice such that you don't forget the method. Now try to tell directly what the average value of the negative half cycle will be. You know, whatever positive
Minus 2 by
values,
pi.
whatever positive values it takes in the positive half cycle, the sine function takes the same negative values in the negative half cycle. So this average is going to be minus 2 by pi. Okay, this is for the sine function. Now the EMF function we have is E naught sine omega t, right? This part of the equation is variable. This is a constant. The peak value is a constant. BA omega, we derived that in AC generator derivation. Now for this variable part, the average value in the positive half cycle is 2 by pi. If the average of that bracket is 2 by pi, if you are multiplying that bracket with E naught, it means every term of this variable function is being multiplied with E naught. If every term is multiplied with a constant, then the average also gets multiplied by the same constant. Okay, these are all mathematical ideas. So you can say that the average EMF in the positive half cycle. Can one of you tell me the value now? It is E naught multiplied with the sine function, and you know the average of the sine function. So tell me
2
what.
naught by pi.
That's all. It will simply be 2 E naught by pi. And similarly, in the negative half cycle will be minus 2 E naught by pi. Okay, Isha, is this clear?
Yes, sir.
So remember, you need to memorize this. For the sine function, generally it is 2 by pi for the entire positive half cycle. If you multiply that with any constant, the average also gets multiplied with that constant. Okay. Now using this idea, integral y dx divided by integral dx, you can tell the average in any interval, not just half cycles and full cycles. Even if you are asked from 0 to pi by 3, you can tell the average. 0 or pi by 3 to pi by 6, you can tell the average, or pi by 6 to pi by 3. Okay. In any interval, you can find out. Right. So that's one thing you need to know how to do, how to find out the average of a function. Variable EMF will give rise to variable current. So you should be able to find out the average value of that current as well. We can do it. We'll use similar ideas. Another thing we'll be interested in is the root mean square value of a function. Okay. Root mean square or RMS. In 11th class, you may have heard of RMS velocity of gas molecules. Okay. Here, since the EMF function is variable, as I said, the current produced in the circuit will be variable. It will be an alternating current, and the power consumed in the circuit will also be variable. You know that power consumed by a resistor is I square into R, or you can also write it as V square divided by R, where V is the voltage, R is the resistance. Now, if the voltage is variable, the power will also be variable. Okay. But the example that we were discussing, when you buy a bulb, the bulb will have a constant power rating mentioned on it. I think I erased it. Never mind. It'll have a constant power rating mentioned on it. That power rating is basically the average of this. Okay, average power consumed is what you should be able to find out. So you need to know how to find out the average of the square of EMF function, because power is V square by R, and you need to average that. Okay, let us do that now. The EMF function is a sine function multiplied with E naught, of course, that we can do later. So what we now have to find out is the average of the sine square x function. Consider this function now, y is equal to sine square x. Calculate its average in one time period. or calculate the average from x is equal to 0 to x is equal to pi by 2. So it's the same idea, integral y dx divided by integral dx. So you'll be doing integral sine square x dx from 0 to pi by 2 divided by integral dx from 0 to pi by 2. Denominator is easy to deal with. Can any of you tell me how to integrate sine square x dx?
Your integration by parts.
How do you do that?
I'm not really sure, sir. One second, try solving.
Okay, Isha, any idea how to integrate y is equal to sine square x dx?
Divide by cos square x and tan square x का integral.
No. See, if you divide by cos square x, when there is x, the function, it becomes a function, it becomes a variable. You can't simply divide by a variable and form another function. No.
Okay.
And how do you know how to integrate tan square x? Secant square we can integrate. Secant square x integral is tan x.
Yes, so we don't have a formula.
Anyway, he said something called by parts. It may work. I don't know that method. But when you want to, if you want to integrate sine square x, there's one easy way to do it. Think of a simple formula which involves sine square x. And that simple formula that I can think of is cos 2x. Can one of you tell me what cos 2x is equal to? Okay. You can write it as 2 cos square x minus 1. You can also write it as 1 minus 2 sine square x. So we'll use the second result. Send the 2 sine square x this side. Then the cos 2x will go that side. Then sine square x becomes half of 1 minus cos 2x. So integrating sine square x is same as integrating this. And cos 2x integral is easy. It is 1 by 2 sine 2x. Okay, I prefer this method of integrating sine square x. If you have a more convenient way, you can follow that. But is this idea clear? How to integrate sine square x dx? I didn't write dx.
Yes.
Yes.
You can use this same idea to integrate cos square x also. You'll have to use the first result. You can write cos square x is equal to 1 plus cos 2x whole divided by 2. So half of 1 plus cos 2x. And if you want to integrate this, you can integrate this. So remember, for integrating sine square and cos square, you can make use of the cos 2x function. Okay. So I want you both to do that now. In the numerator, we'll evaluate the numerator first. In the numerator, we have integral sine square x. That is basically half integral of 1 minus cos 2x. And we know how to, okay, dx also should be written. And integral 1 is x minus integral cos 2x is 1 by 2 sine 2x. You have to substitute limit 0 to pi by 2. Not pi, why did I give you pi by 2? Okay, no problem. You can do pi by 2, not an issue. That's the numerator. And divided by the interval. Interval is 0 to pi by 2, that becomes pi by 2. So divide the whole thing by pi by 2. Substitute the limits and tell me the answer quickly. Any answer? Okay, let's substitute the upper limit. This by 2 can be cancelled. I'll do that. And then in the numerator, you will be left with pi by 2 minus half sine 2 into x. 2 into pi by 2 is pi. Okay, that's what you get when you substitute the upper limit minus. Now substitute the lower limit. You get 0 minus half sine 2 into 0, that is 0. The whole thing becomes 0. And in the denominator, there is a pi. Okay. Now sine pi, sine 180 degrees, this term is 0. This entire bracket is 0. You will be left with pi by 2 in the numerator and pi in the denominator. The answer is half. Okay. Do this calculation once on your own later. But what have we found out now? We found out the average value of sine square x function. And in what interval? 0 to pi by 2. Just a moment. Try to answer this question now. Average score of, let's say, section A is 75 and average score of another section C is also 75. Now, if you club A and C together, what is the average score? Think about it.
Sir, is it 75?
It will be 75 itself. Okay. See, you have already averaged for all of section A and all of section C. Then if you put them together also, the average will be 75 itself. Okay, you can try this with some numbers if you want later. In section A, okay, instead of 75, let's take 20. That will be an easy thing to do. Suppose in section A, the scores are like this. 10, 20, 30, average is 20. In section B, let's say the scores are like this, 20, 20, 20, then average is 20. So both section A and B, okay, section C, both section A and C have averages 20 itself. Now we want the overall average. If you want, you add all these numbers and see, you have like sum of all this is 120 divided by 6 scores. The average will also be 20 itself. Okay, it will always be like that. So what I'm effectively saying is, if average of one interval is same as the average of another interval, then when you combine those two intervals also, you'll get the same average. Now we found mathematically the average value of sine square x in the interval 0 to pi by 2. Now you look at this. This is the graph of sine square x. Okay, let's mark the intervals. This is 0. This peak value, pi is 3.14 divided by 2 is 1.57. This peak value will be at 1.57. That is pi by 2. Then again it becomes 0 at pi. Then at 3 pi by 2 it will again peak. Then 2 pi it again becomes 0 and so on. This is the sine square x graph. Now you look at the graph and tell me the values that it takes in the interval 0 to pi by 2, are they same as the values that it takes in the interval pi by 2 to pi or not? That red part and yellow part, are they the same values or not?
They are, sir.
Yes, same.
They are. That means whatever is the average from 0 to pi by 2, same will be the average from pi by 2 to pi. And same will be the average for both the intervals combined also. Okay. So this entire interval has an average of half for the sine square x function. And this entire interval also has an average of half. Now 0 to pi, the average is half. Pi to 2 pi, the average is half. Means 0 to 2 pi. Why am I interested in 0 to 2 pi? This is one time period of the original sine function. One time period of sine x. Okay, in one period of sine x, you'll have 2 periods of sine square x. Mathematical stuff, I don't want to go into the details. So in one time period of sine x, that is from 0 to 2 pi, the average value of sine square x. See, these are angular brackets. Angular brackets indicate average value. Average value of sine square is half. Okay, we'll stop it here for today. So what have we learned today? First thing is, basically we revised how an AC generator works, what are the components, and what is the kind of EMF it produces. If omega is constant, you get a sinusoidally varying EMF like this. Then the main thing we discussed today is how to find out the average value of this function in a given interval. We took the positive half cycle, negative half cycle, we found out the average. Generally for sine function, positive half cycle average is 2 by pi. Negative half cycle average is minus 2 by pi. If the sine function is multiplied with something else, then the average also gets multiplied with that. So E naught by 2 pi minus E naught by 2 pi. Revise these ones. Then we derived the square of the sine function, and I mean average of the square of the sine function. In one time period, we just found out that it is half. Okay. So next class you will have tomorrow mostly. I'll inform the timings. We'll continue with this. We'll enter into the actual chapter, alternating current. But this,
Tomorrow I have an exam from 5 to 8.
okay. Afternoon, like around 2 o'clock, will you be able to attend?
Yeah, sir, 2 is fine.
Or evening after 8 also is okay?
It might get late before, since I get here, so
Okay. Fine. I'll ask you all and confirm. If not, I'll take on Monday.
yes, sir, sure.
Is Monday okay? Monday evening, 8 o'clock.
Yes, sir, yes, sir.
Isha, is it okay for you Monday?
Yes, sir.
Okay, so I'll take on Monday itself, not tomorrow. So we'll be applying all these in this chapter. We'll need to find out what is the average current, what is the average voltage, what is the average power dissipated. In those things, we'll be using these calculations. Okay, thank you all. We'll continue in the next class.